Okay, so here I told you about these representative characteristics of light and matter interaction. So this fundamental property, I didn't cover all of them, but I'm gonna go through, define one by one. This is the most important basics for you to be able to understand more deeper and microscopic optical imaging. So the first properties of reflection. Everyone knows what reflection is. Reflection is a phenomenon that return of the wavefront when it hits a medium and it comes back when it meets at the interface of different media. At the same time, some waves will come in, but they could bend their path. That we call refraction. So changes in the direction of a wave due to a change in its transmission medium. So fundamentally, it's also meaning that the speed of light is changing. So that's why index of refraction is defined based on the speed ratio with respect to speed of light in the vacuum. And another important characteristic which I didn't cover much is called dispersion. So you remember the function of a prism, which actually shows our sunlight or white light is in fact composed of many colors. So the prism works as a dispersion element. That dispersion is the way wave velocity is function of color. Okay, so dependent on wavelength, or at the same time we can say frequency. So that phenomenon is called dispersion. And the most fundamental property for image formation is in fact diffraction, the bending of the wave when it encounters an obstacle. This is fundamental phenomena. A good example for you about the dispersion, diffraction is sound wave. So you know that you can hear when I have this bar in front of me, this iPad, you can still hear. The reason is the sound wave has a longer wavelength compared to this side, so it can actually bend through to these speakers. So such that you can actually listen to my voice, even I block my mouth with an obstacle. Okay, so that's a diffraction. And light specifically has a kind of orientation of electric field and magnetic field. So that orientation we call polarization. And of course, of this wave characteristics, we can actually utilize this to create a contrast. I exemplified it as a ophthalmology clinic, and interference of light based on superposition of two or more waves, resulting in new gross pattern formation. And there we can extract information based on this wave nature, which has a wavelength of about several hundred nanometers. In fact, this one gives us a very fine and sensitive distance or spatial characteristics of the object. So all of this, from the physics point of view, and this comes to the question of, hey, wait a second, I heard scattering, light scattering, maybe in physics class or something. So in fact, this all terminology can be very confusing, but I want to discuss about the fundamental nature of the light, which is some form of this radiation, such as light and sound. They are propagating and forced to deviate when they hit a particle, okay? From this straight trajectory by one or more of localized non-uniformities in the medium when they pass and they kind of change the direction. And this phenomenon in general we call as a, this is a scattering. And scattering is very, very fundamental characteristics of light when it encounters with the matter, okay?